Okay, let me go over the calendar here. We did trig inverses yesterday. Today, I felt like 4.18 is just more of the same. And I would like to skip over to 4.19. So that we can kind of get an early start with the new, these are two new topics, but they're not difficult. We just need to spend some time with them, getting used to them. So I'm gonna spend today going over 4.19. Tomorrow will be 4.20. Yes.
So what we did yesterday, is that gonna be on the quiz?
Yes.
And you're gonna have it calculator for that also?
Yes, yeah,
Okay.
yeah. And then, that way we can reserve Thursday just to have a full review day, with the quiz, topics. Friday, there's gonna be an early release on Friday. So we're gonna take the quiz and whittle it down from 8 questions to 5 questions, so, I think after a couple of practices, we should be able to, let's just be, half a page. We should be able to get through that within whatever our schedule is gonna be, 35 or 40 minutes, of that class period. Okay. And then after that, all we have left is solving, trig equations. So we'll spend, 3 or 4 days, going over trig equations. I'll try to get through. Oh wait, there's an issue here. The 6th is a remote day. So, but I'm still going to have a help session just going over trig equations. I'll find out more information in terms of the schedule for that day. And I think, yeah, it's just a remote day, but I'll have a help session. It's not required, but I'll just have a help session for if students want to do that. And then, but I do want to kind of cover material a little earlier in case students want to take the test early. The test is going to be on the 13th, but I know some students may want to take a test either Monday or Friday. If that's the case, then I want to try to get through the material early so students can prepare, and they want to take the test early if they can. Any questions about our calendar or schedule these remaining weeks? Okay, so we're on page 13. I'm going to skip 11 and 12 for now. I'll go back and review them as needed. But I want to pick up on page 13. Before I jump to page 13, though, just want to review something that you already know, and that is with unit circle and reference angles. Okay, so what is a reference angle? Reference angle is our coterminal angles where they're the same degree measure or radian measure away from the x-axis. So all the angles here that I color coded in green, those are all related. Those all have they all have reference angles of 30 degrees because they're all 30 degrees away from the x-axis. And all the middle angles in pink, those are all 45 degrees away. So they all are related to each other because they all have reference angles of 45 degrees. And then all the ones in orange, all the 60-degree related measures, 60, 120, 240, 300, they're all related in the sense that they all have a reference angle of 60 degrees. Created something here. Show you guys. Okay, so yeah, just to kind of highlight that again, for instance, 30 degrees, 150, 210, 330, they're all are 30 degrees away from the x-axis, from the nearest x-axis, right? So 360 minus 330, that's 30 degrees, that's 30 degrees. 180 minus 150 is 30 degrees. 210 minus 180 is 30 degrees. Those are all reference angles. They all share a reference angle of 30 degrees. And we only look at that degree difference between our our terminal side and the x-axis. Okay, we never look at the y-axis. Okay, reference angle is always in comparison to the nearest x-axis. Okay. Right, likewise, 45 degrees, 135 degrees, 315, 225, they all are related to each other in the sense that they all share reference angles of 45 degrees. Because they're 45 degrees away from the closest x-axis. And then, right, so 60, 120, 240, 300 degrees, they're all related to each other because they all are reference angles. They all share the same reference angle of 60 degrees. Because they all are 60 degrees away from the x-axis. Is that clear? I mean, this is going to be the foundation for what we're going to do today and tomorrow. So if you're comfortable with reference angles, then you should find what we're going to do today and tomorrow very straightforward. Okay. Right? Everybody good? Reference angles? Okay. Good. So let's look at page 13. Okay. We're going to refer to our unit circle a lot here. Okay, it says find inverse sine of 1/2. Notice that there's an uppercase S here. So that uppercase S indicates that we have that domain restriction, principal values. Okay. So in other words, where is sine of theta equal to 1/2? And theta is what? Yeah, 30 degrees. So today, we're going to do everything in terms of degrees. And tomorrow, we'll do the same thing, but everything in terms of radians. Okay. So degrees just feels easier. So that's why we're starting with it. And then we'll pick that up with radians. Okay. And then with the calculator, if you do inverse sine of 1/2, you get the same thing, 30 degrees. We talked about how sine and tangents have something a little bit different if it's negative, right? Fourth quadrant. And the cosine is just second quadrant if it's negative. Okay. Okay, so how would you solve inverse sine? So now we're back to lowercase s. How would you solve inverse sine of 1/2 for angles between 0 and 360? Where else is sine positive? Second quadrant, right? So now that we're down to lowercase s, now we can look at a quadrant other than first quadrant, right? So what's related to 30 degrees in the second quadrant? 150, right? And that's all because of reference angles, right? 30 degrees away from 180 is 150. So that's how we know. Okay. How do you find this angle using angle measurement found in number 1? We just look for reference angle, subtract 180 minus 150. Sorry, 180 minus 30, which is 150. Let's take the two answers. Where inverse sine of 1/2 equals theta. Okay, we're just renaming what we've already found. Okay, find inverse sine of negative 1/2. Okay, uppercase S. Okay, restriction here. So which quadrant are we looking at here? Fourth quadrant. Okay. So normally we would say 330 degrees, but now we're going to say what? Good, negative 30. Right? So yeah, we did that a lot with radians, so we're gonna just adapt it with degrees, okay? So instead of 330, we'll say negative 30 degrees. Okay, trying entering that into your calculator, and you should get the same thing. Make sure you're in degree mode. You can double tap sine to get that inverse sine. Yeah, negative 30 degrees. Okay, why did our calculator give our answer of negative 30 instead of 330 degrees? Because your calculator is always going to give you your principal values for inverse functions. And it's between negative pi over 2 and pi over 2 for radians, but for degrees, it's going to be between negative 90 and 90 degrees. Right, between fourth and first quadrant. Okay. So how do we solve inverse sine negative 1/2? So now we're back to lowercase s between 0 and 360. Okay. Where else is sine negative? Quadrant 3 and 4, right? So we need to adapt that. Okay, so now we can go back to using 330. We can use 210 and 330, right? They both have reference angles of 30 degrees. Okay, number 5 says write a formula that uses principal value solution for inverse sine to find the second answer. So the principal value was negative 30. If I want to get that over in the third quadrant, I'll just add 180 to it. Okay, so I feel like some of these notes is just kind of repeating what we already know. We know that inverse tangents, we're dealing with the fourth and first quadrant, right? Inverse cosine is between the first and second quadrant, and we just got through it with the quiz. So let me just skip this section and let's go to the practice problems. Okay, I think we just that way we can kind of see things more clearly, and I feel like we're kind of just rehashing the same things that we already know. So let's go to page 14, and let's go down to these examples here. Okay, so let's look at these examples. Let me use a separate sheet of paper here. Okay, use your formulas to find each of these degree measures using your calculator, round to the nearest degree. Okay, so part A. Okay, so we want to find inverse sine of 0.1736. So the reason why we need a calculator, because this is not a ratio that we recognize on the unit circle, but it's lowercase s, and it's between 0 and 360, so we should rely on our knowledge from ASTC. No need to do any principal values here because we're dealing with just lowercase s. So in other words, we want to find theta where sine of theta is equal to 0.1736. Okay. So but we can make our calculator do the work here. So inverse sine 0.1736. Make sure you're in degree mode. Okay. 9.997 degrees. You guys get that? Now, remember, whatever you get for theta is only going to be the reference angle. Okay. We have to look at the distance from the x-axis if we want to find what we are looking to find. Okay. So the four possibilities are adding or subtracting 9.997 away from 360 or away from 180. Right, just like how if we were to find a reference angle, we can find all the reference angle by subtracting from 360 or 180. Okay, where is sine going to be positive though? One and two. Okay, so now quadrant one is easy because that's whatever you get for theta, whatever your reference angle is automatically going to match your first quadrant answer. So we know theta is 9.997. That's easy. Now, what's going to be the angle in second quadrant that has a reference angle of 9.997 degrees? How we find this angle? Good. Yeah. 180 minus 9.997. That's it. So if we understand that we're always going to get a reference angle in return, and we just have to figure out which quadrant we're in and just either add or subtract that reference angle from 180 or 360, we'll be able to land in the quadrant that we want to land in. $170. Does it say to round? Okay, sorry, it says to round, so I should say 10 degrees and 170 degrees. Okay, the rest of the problems are going to feel like this. So any questions? Because if you can get this, then everything should feel like the same thing. Yeah.
Can you write down to 170 again?
Yeah, 170. So we know we're dealing with the first and second quadrant, right? So 0 plus 997 is that's first quadrant degree measure. We want to find a measure that's in the second quadrant, but that has to be 9 degrees away from 180 degrees. So 180 minus 9 degrees will be 170 degrees.
So you reference.
Yeah, so you always use your reference angle to figure out which angle measure you're looking for in the correct quadrants. Yeah. Good. Any other questions? Okay, let's look at part B. Okay, so in other words, we're trying to find what theta value will allow cosine to be negative 0.6427. Well, we're going to make inverse cosine do the work here. Make the calculator do the work here for us. Okay, what's good for theta? Okay, we're gonna round to nearest degree. Okay, let's step back for a moment. Moment here. Which quadrant are we considering here? Good. If we want something related to 130 degrees in the third quadrant, go ahead and put 130 degrees in the second quadrant here. Okay. What is the reference angle for 130 degrees? What's that degree difference to the closest x-axis? 50. So if we know what the reference angle is, we can use that to help us find the third quadrant measure we're looking for. What's 50 degrees away from 180 in the third quadrant? Yeah. There we have it. We want second and third quadrant that share the same reference angle. So 130 and 230. Yes.
Using the second and third.
Because where is cosine going to be negative? Second and third. Yeah. So we always want to look at the sign to help us narrow down. We're always looking for two answers. And we're always looking for the correct quadrants that we want to live in. Okay, so whatever you do, all your answers will be the same reference angles, right, as each other. Okay, part C. Inverse tangents. What do we get for theta? -7. Okay. All right, let's think for a moment here. Which quadrant do we want to live in where tangent is negative? Second and fourth, yeah. -70. We know that's in the fourth quadrant, and also that's going to help us understand what our reference angle is. This is going to be 70 degrees. But we want an answer between 0 and 360. So we want two angle measures that's 70 degrees away from the x-axis. How do we find the one in the fourth quadrant? Good. 360 minus 70. And how do I find a second quadrant measure that's 70 degrees, that's 70-degree reference angle? Good. 180 minus 70. There we have it. We're looking for 2-degree measures that are in between 0 and 360 in the second and fourth quadrant. And we both want them to share the same reference angle. So 110 and 290. So this 70 degrees is really helpful. This kind of gives us an idea that we're talking about a reference angle of 70 degrees. We want second and fourth quadrant, so we want an angle measure that's 70 degrees away from the x-axis in the second and fourth quadrant. So if I want something in the fourth quadrant 70 degrees away from the x-axis, I do 360 minus 70, and that gives me 290. And if I want a degree measure that has a reference angle of 70 degrees in the second quadrant, I do 180 minus 70, and I get 110.
Negative 70 degrees an answer? Is what you're answering?
Negative 70 degrees is sort of an answer, but if we look at the direction, it says we want a theta between 0 and 360. So a version of negative 70 in the between 0 and 360 will be the same thing as if I added 360 to negative 70, and I'll get 290 as well. Okay, number 1. Okay, enter into your calculator. What do you get for theta? 29, okay. We gotta make some adjustments potentially. Which quadrant do we want to be in? Cosine is positive in the first and fourth, okay? So 29 is already what we want. It's already in the first quadrant. So likewise, we want an angle measure that's shares the same reference angle, but in the fourth quadrant. So how do we find that? Good. Yeah. Okay, how do you guys feel so far? Makes sense? Okay. Let me do 1 through 4 with you, just so I can make sure that you're really comfortable with this process, and then I'm gonna have you guys do 5 through 9 on your own, okay? All right, so let's try 1 through 4 here. Okay, which quadrant do we want to give our answers in? First and third. So that 87 is already one of our answers. How do I find my third quadrant degree measure? Yeah, plus 8. Sorry. Okay, which quadrant do we want to be in? Sign is positive and the first, second. No. All right, which quadrant we want this to be in? Tangent is negative and the second. I would just treat that negative 88 and just make it positive and turn it into a reference angle. And then involve 180 and 360 to get to the correct quadrants that I want to be in. Okay, how do you guys feel about this process? Okay. So really the only thing left tomorrow is we're going to do the same thing tomorrow, but from a radian perspective. It just feels more abstract because we don't recognize those radian measures as easily as we do degrees, but if we have this as our foundation, then we're going to do the same thing except with radian measures tomorrow. All right, go ahead and see if you can finish 5 through 9. I'll come and check you off once you're done with that, and that's all we have for them. That's even more famous. But that's not giving you reference. We want something that is same reference in there. In the third one, so let's find that reference in the second. Okay, for number 6, you're gonna get 130 degrees, which is not a reference angle, but it is in one of the answers that you're gonna be providing because one angle measure that's in the second quadrant. But you want a second and third quadrant, so you gotta kind of work backwards a little bit because for the 13, it's not a reference angle, but you can find the reference angle by subtracting from 180. If you know your reference angle is 67, you can use that 67 to help you find the corresponding angle in the third quadrant, which is 180 plus 67.
Why would it be 67? Why would we want 13 instead of 67?
Because we want where cosine is negative. So it's gotta be in the second and third quadrant.
What's 13 was then? What's it?
Remember, reference angle is always an angle measure that's between 0 and 90. Right. Yeah, has to be a positive and degree measure. So if they give you something related to reference angle, you have to kind of find that reference angle before you can get to that, the third quadrant. Yeah, but reference angle always has to be has to be positive and has to be between 0 and 90. Are we okay with 5 and 6? Tomorrow we'll do this from a radian perspective, and then we can have Thursday to do quiz review, Friday quiz. Okay, don't forget your phones. Yeah, got it. Thank you. Oh, they're the same. Our side is inverted nine and one. For all of them.
There's so shit.
Don't matter.
No, you matter, you matter.
It's mid.
You matter.
It's
Thank you, Connor.